All right, this video is focusing on reading in data. And so Tyler just went over talking about data, how to make data tidy and ready to be read into R. And so now we're going to jump into what it means to read your data into R and explore it a little bit. So you can see I'm in my class project. I'm in my home directory, which we can see on the bottom right-hand pane over here. And I've opened up a script and already saved and named it in my scripts folder. So as a reminder, you can open up a script either through this sort of drop down R script or file, new file, and then choose R script. And we'll start with a blank template for today's notes. And so the goals of this talk, like I said, are to read in data. And what specifically this means is using the read.csv function, exploring and subsetting data frames, and talking about the idea of packages, and then what that means for operating in sort of a language that we'll refer to as base R versus the tidyverse. So let's jump right in. First, we want to read in data. And there is one function that will be very much in handy, which is the read.csv function. And you can read a little bit about it in the help file or in sort of this tab information that pops up. But we are going to open up parentheses and give it one key argument to start, and that is the file name. So here we can do file equals, open up our quotation marks, and throwing it back to last week, this is why it's really important to know where your data is stored, because you have to tell R where to read in the data folder that you have. So because we're in our project working directory, we know that we can just start with this data folder. So we say, I want to go into the data folder, /, and then you can choose one of the CSVs. You can fully type this out. You can press tab on your keyboard and likely have these prompts. And we want to be reading in the portal_data_joined.csv. So this is our complete function to read it in. But oftentimes, I mean, all the time, more or less, you'll want to assign your data to a name. There are some pretty typical names. You'll maybe say like data or DT. We are going to call this surveys for our rodent surveys, and we'll use our assignment arrow to give it a name. And then we'll run this line of code with, kind of your command enter shortcut or by clicking the run button up here. And now we have an object that is saved in our global environment called surveys. And we get a little summary about it. And we can now inspect this using some of our code. So inspecting the data, what do we know? We just read in this CSV file, but none of you really know very much about it. So some ways of checking in on the data are first to maybe use some of these n-based functions. So nrow and ncol are short for number of rows and number of columns. So we can try that nrow surveys. So each time we're going to open up a function, and then typically a lot of the functions that explore data, they only need one argument, which is the object itself, the data object itself. So we did nrows surveys, and we get an output in our console that also matches our summary in our global environment, which is that there are nearly 35,000 rows. Similarly, we can do ncol for n columns, also with one argument surveys, and we have 13 columns. So we kind of get a sense of the dimensions of our data. We might also want to ask R, what kind of data is surveys? And now at this point, we've talked a little bit about different data types in R, and it's good to start getting used to these kinds of questions, checking in on different formats. Are we talking about data frames? Are we talking about a single column? And so there are two different functions that can often tell us a little bit about the data, and those are class. So what is the class of data? And here, if we open up class, again, just one argument, which is our data surveys, and it tells us that it is a data.frame. And so we've started talking about this a little bit, but this is probably going to be, for those of you who work with observational data, most data are these dimensions. It's just like tabular data. It's going to look a lot like what an Excel spreadsheet looks like. And you can sort of, one way we can do this is we can open up surveys. We often don't want to be trying to visually assess our data because the larger it gets, the sort of harder that is to do with any accuracy. So we want to be using our functions, but it is nice to sort of look at the data and check in on that. And you can do that either by clicking on the name of the object in the global environment. So I'm going to do that now, and it actually opens up a new tab in RStudio that shows me the data more or less how you would imagine it from like whatever CSV you're reading in. And you can, of course, scroll through it, you can find it. And you'll also notice that what this clicking on that name actually did was generate a function in your console that is view with a capital V of the survey object. So if you actually do that yourself, view surveys, it will open up that tab for you to take a look around. A second kind of function for looking at what kind of data surveys are is the type of function. This is likely going to give us the same, nope, it gives us a kind of higher level output. So we'll get used to talking about the idea that there are lots of different data types. There are types and classes, and they're sort of hierarchically nested. So a data frame is a type of a list, and a list is a higher, more general category of data types. All right, more exploration. We did this last week with vectors, but we often want to look at the top or bottom of the data. Why do we want to do this? It really has to do with size, right? So we can, of course, look at surveys, and we can kind of look at the top. We can scroll all the way down, but the bigger your data get, the harder it is to sort of eyeball this and scroll through it. And like Tyler said last week, just printing surveys into your console. So if I just typed surveys right now, it would likely print it all. But it kind of, what you get is this long output that is even worse to look through than the view thing, where it will give you some number of outputs, and then it will start telling you that R has actually reached its max. It doesn't want to print anymore. And so, this is long and really can freeze R if data is too large. And so what we'll often use are these heads and tails functions. So we will open up head, and it takes one argument by default. I just want to look at the top of surveys, the head of it. And what is then printed out in your console by default are the first 6 observations. So this gives you a snapshot of your data without having to print it all out, and it's a lot more manageable to view. Similarly, tail of surveys will give you the bottom 6, and this can just give you a good sense of like, is all of your data in the format you expected it to be from top to bottom? And we talked about this a little bit last week, but it's always good to remind ourselves, like, what if I actually wanted just the top 4, or I wanted the top 10? And there are some optional arguments inside the head function, so I did the question mark and then wrote the function that I'm interested in, and then ran that line of code in RStudio, and it opened up this help window for me. And you get some information, and it says that there is X is our one key argument, which is what we're using surveys in. But then there's this kind of N equals 6L, which not all documentation is great, but this tells you a little bit about N. It's an integer vector. This essentially says, how long do you want it to be? And we know that its default is 6 based on how it's been built into the function's description. And so we can do something like head surveys, N equals 10, and we'll get the first 10 observations printed out. A little bit more of these data just to get us into the practice. These are functions that are really useful to kind of have on the top of your head. Again, we don't need to memorize all of these, but they will come naturally over time as you start exploring data in your work. And this is to look at the structure and summary. So we can know, other than just reading a little bit or reading the exact output, we can know a little bit about how R is thinking of the data. So this first one, str, again, we open the function inside our parentheses, only need surveys, our surveys data object. And this gives us the structure of each column. And so here we're revisiting this idea of data types, where we have the name, and yeah, there's a lot of information packed in here. So this structure tells us first that surveys is in fact a data frame, and it gives us the dimensions, right? It's almost 35,000 observations or rows and 13 variables or columns. And then it tells you each one of those 13 variables by name. So this $sign is indicative of a column. then the column name, then the type of data that is in the column. So here we have int and chr. Int is short for integer. That's a little more intuitive when you start looking at the kinds of data that are inside that column, and it lists a certain number of them. It looks like about 10. And some are CHR or character, which then again, if you look at what these are, you'll see they're in quotation marks and they are letters. And so these are sort of two key different data types that it will often see in data. And the summary function will give us a pretty similar output, though it's always summarized a little bit differently. So in addition to giving us some column by column information, it will also summarize that data by giving, the min, max, quartiles, mean, and median for integer data. But you'll notice you cannot give those summary statistics for character data. So for data types of the class character, it will really just count up how many there are and does not give much further information. All right, and so moving now to indexing. Last week, we talked a little bit about indexing vectors and started talking about indexing with multiple dimensions. And the important thing about indexing is that this is trying to extract a piece or a particular part of the data, whether that's from a vector or from a data frame. And in this case, we're extracting data from a two-dimensional data set, right? And in our two dimensions are our rows and columns. And this becomes important because the way that R thinks about extraction will respond to kind of these two arguments, an argument about row and an argument about column. Argument is not quite the right word because the indexing brackets that we've learned about are not functions, but it's important to know that inside, right, we have something like a data frame. And when we open up our data frame, we do that with those square brackets. And so these square brackets are saying, hey, I want to go inside this thing called data frame. And then within those square brackets, we have to be specific about the two dimensions that exist inside that data frame. And that is going to be row on the left side of a comma and column on the right side of a comma. We talked a little bit about last week about, why do you have to subset, like use the concatenate function within subsetting, and we'll review that. And it's because this comma inside the square brackets has a really particular meaning in that it divides the dimensions, whereas a comma inside the concatenate function means something else. So let's actually talk about that. So we have our surveys object. And so we're going to open up our square brackets to tell R, I want to pull out something specific in that surveys data frame. And let's say I want just the first row of the first column. That means I'm going to say 1, 1. And if I run this line of code, I'm going to get 1. That makes sense that that's likely it. This is where you could use your visual check-in if you wanted. And we know that the column 1 is record ID, row 1 is row 1, and the record ID in row 1 is 1. So that has printed out this specific cell. But if I wanted to delve deeper, let's say I wanted to take the first row and the 6th column, we'll see that it is, I think, the species ID NL. Now, R is a little tricky in that we have these dimensions, but if not specified with a comma, it will default to the column dimension. So what does this mean? If I go surveys, and then let's say I don't put in a comma, I just say I want 6, it is going to by default print out the 6th column, not the 6th row. And that's just good to know, right? So this is the same as saying this. If I open up my brackets and then I want all of the rows but the 6th column, I can put in a comma, but I just need to put 6 on the right-hand side of the comma and nothing on the left-hand side of the comma, and nothing in one of the dimensions means everything. Right, so if I run this line of code, it will be a slightly different format, but it is still, again, just the 6th column. And we can talk about this format, this difference in format in class. Okay, so we also talked a little bit last week about vectors and how there are different, signs, or I think they're technically called operators, for helping us subset. So we learned a few of them last week. I think that the colon represents a range, and the negative sign subtracts. And we have to remember that this function, the concatenate or C function, helps us list values in a vector. So let's apply that. So if I want to take my surveys object and I want to index something, but let's say I want to index rows 1 through 6 for all of the columns, which is actually imitating the head function. I would say 1 through and use the colon to represent through 6, comma, and here we are, rows 1 through 6, and all of the columns is what I'm indicating inside these square brackets. And we can see that output in the console. Again, just 1 through 6. So all columns. If we do, again, surveys, but try to use our negative sign, we can also, let's say we want to just subtract the first, like remove the rows 1 through 6. I'll do an important thing here where if I just say I want to remove 1 through 6, comma, I think we'll get an error. Yeah, and it says error, only zeros may be mixed with negative subscripts. Not a great error, but we know that something is a little bit confusing about this one, so this throws an error. Why? And that's how R wants to apply that negative subscript across the range that you're giving it. And what I mean is that we want to make sure that we are removing 1 through 6, not removing 1 and then something through positive 6. And so we're going to put the negative and then use parentheses to say 1 through 6, comma. And this should remove rows 1 through 6. And you can sort of check your work by saying we're starting actually at row 7 when it prints out in the console. But you don't need those parentheses if you just have one value in here. So let's say I just want to remove only row 1. We can run this line and we will have removed row 1 and we can see that here by starting at row 2. So that's really kind of focused on rows, but what about subsetting by column name? So you'll notice we've used numbers up here a lot to deal with subsetting rows. And you can also use numbers to subset columns, but often we don't know our columns by their number name. And sometimes columns move around, sometimes we reorganize them, and sometimes we rename them. And so generally, while you can say, I want column 3, so I do surveys, nothing, column 3, and I can get the value of column 3, I don't actually know what that column is. And so it's a lot easier sometimes to just subset the column by name. So what are my column names is the first good question. You can use the function call names. So this COL is often short for columns. And I would say call names of surveys. And then you can have the console print out all of your column names, which is then useful because let's say, okay, I want to subset column 3 now, but I want to do it by name. And it happens that column 3 is day. So now I can start with my surveys object, open up the square brackets, put in a comma, and on the right-hand side of the comma, because we're talking about columns, using quotation marks, I can type in day. And this will now give me the same output as before, as when I put 3 on the right-hand side of the comma, but it's kind of easier to identify the output and is sort of resilient to changing column position. Because if you happen to move things around and later along in your code, you still thought column 3 was day and it wasn't, you might have some unhappy results. But another common way you'll see subsetting, by the way, you'll notice I'm using the word subsetting interchangeably with indexing. This is my own personal thing. Tyler and I debated a little bit about it last week. So maybe I can say indexing to keep it consistent, because subsetting can sometimes mean something a little different, but we're indexing by column name. But often the way that folks will extract a single column is through the use of the $sign. And this is really nice because instead of using these brackets and these two-dimensional things, if you're really focused on a column, you can type in your data frame object, put the $sign immediately after it, and you'll see that R already prompts me with all of the column names. That's great. And so you can then just type or select the column that you want. And we'll see that this again prints out the third column. But it's the nice thing about it, in addition to being resilient to changing column numbers, is that it also helps you avoid typos, because sometimes typing column names on their own in quotation marks inside indexing brackets is a bit hairy. Okay, we're gonna pause here, and the next video we'll jump to is just on reviewing these very same things, but in the tidyverse, where we're going to talk a little bit about packages and kind of these different languages of R.